Hi, good morning to all. So, welcome to my channel Firjan. Today we discuss derive an expression for capacitance of parallel plate capacitor. Parallel plate capacitors. This we can derive. See, derive an expression for capacitance of parallel plate capacitor. See, for example, here parallel plate capacitor. So, these are the parallel plates. Is positive charge, it has a positive charge, it has a negative charge. See, its area of cross section, A is the, let us consider, A is the area of cross section, area of cross section of each plate. Area of cross section of each plate is A. See here, a distance between the plates is D. See here, D represents a distance between plates. Distance between plates is small d. Here na sigma surface charge density. Surface charge density, sigma represents surface charge density. Sigma means charge per unit area is called surface charge density. Charge per unit area, how much charge is present in the plate in unit area, that is we call it as surface charge density. E represents na electric field. Electric field. See, E represent electric field. In this parallel plate capacitor, electric field is positive terminal to negative, positive plate to negative plate, positive plate to negative plate. This is the direction of electric field. In this case, what is the capacitance in the parallel plate capacitor, that we can derive. For that, electric field we can write. Electric field equal to sigma by epsilon naught. Here sigma is surface charge density. Surface charge density na Q by A, charge per unit area. Epsilon naught na permittivity of free space. See here, instead of sigma we can write Q by A. Q means charge, A means area. How much of charge is present in the unit area, that we call it as surface charge density. Here we can write electric field equal to sigma. Instead of sigma we can write Q by A. Q by A, already epsilon naught is there. So what is the electric field between the plates is E equal to Q by A epsilon, means on what is the electric field now between these plates, Q by A epsilon naught. Q by A epsilon naught. Now see, what is the potential difference between these plates? Is higher potential, lower potential. So means higher potential, lower potential. Here what is the difference? Potential difference between the plates. For that, actually V equal to E into D. Actually what na formula na, relation between electric field and electric potential na, delta V equal to minus E delta D we can write. Here change in potential, E means electric field, delta T means distance. See here, delta V equal to minus E delta D. Here we can write this one, we can write simply E D. We can remove minus sign, we can take magnitude. See EV equal to ED. Instead of E, what we can write now here, V equal to ED. E means electric field, D means distance between the plates, V means potential difference between the plates. V equal to ED. Here see, V equal to E means electric field na, Q by A epsilon naught. I write here instead of A, E we can write Q by A epsilon naught into D. So this is the potential difference between the plates. Now see, actually capacitance equal to what na, charge equal to what na, CV. Capacitance equal to Q by V. So means here capacitance of the parallel plate capacitor we want to derive. So C equal to what? Q by V. What is Q value? So Q charge. V means potential. What is the potential difference between the plates? QD by A epsilon naught. Here Q cancel. C equal to what? A epsilon naught by D. Why not? It will be changes to numerator na? A epsilon naught by D. Capacitance of the parallel plate capacitor is A epsilon naught by D. A means area, epsilon naught na permittivity, D means distance between the plates. A epsilon naught by D is the capacitance of the parallel plate capacitor. Now see again, derive an expression for capacitance of parallel plate capacitor with air between the plates. In between them air is there. In that case, what is the capacitance? Capacitance means property of the material. It's not capacitor na device. That case, A, area of cross section of each plate. Each plate area of cross section is A. D is the distance between the plates. In between the plates some distance is there, that we can write as small d. Sigma na surface charge density. Surface charge density means charge per unit area. In unit area how much charge is there, that we can write sigma. See, E na electric field between the plates. For electric field na sigma by epsilon naught. Sigma na surface charge density, epsilon naught na permittivity, E equal to what? Sigma by epsilon naught. Instead of sigma what we can write? Q by A. Here we can write Q by A epsilon naught. See, we can find out what is the potential difference between the plates. That is V. We can represent relation between V, potential difference, electric field and distance is V equal to ED. Actually delta V equal to minus E delta D. V equal to ED we can write it. So that we can take here V equal to ED. E means Q by A epsilon naught, D like that. So means V equal to what na QD by A epsilon naught. Actually Q equal to what? Charge equal to capacitance into potential difference or voltage. So means C equal to what? Q by V. Here we can derive capacitance na, we can use Q by V. Q like that, V means this value QD by A epsilon naught. See Q cancel, 1 by D by A epsilon naught is there. I write here 1 by D by A epsilon naught is there. It will changes to numerator na A epsilon naught by D. This is the derivation of capacitance of the parallel plate capacitor. Now we can do the problem for this. One more, see once here, what na? Find the equivalent capacitance network shown in the figure. I will show one network here. See, this is capacitor, one more capacitor is there here. See, two capacitors, it is connected series. Here this one, here see one more capacitor is there, it is connected. This is the network, given network. See, for a supply of 300 volt supply, for a supply of 300 volt, this case this is the first capacitor, second one, third one, four capacitors are connected in circuit. In this case, first one, find equivalent capacitance, C equivalence of network shown in the figure. Shown in the figure for supply of 300 volt and calculate charge on each capacitor. This is the problem we can solve now. See once, first we can find out capacitance of the network, equivalent capacitance of the network. For that, see first here, first now for example we discuss what is a series parallel of capacitor, parallel capacitor. So we can see here series, for example here it is one C1 C2, two capacitors are connected in series, means end to end connection. In this case, what is now here, when capacitors are connected in series, charge is same. Here charge Q, here also Q, here also Q. What here na? Potential is divided. V1 here, V2 here. See here potential is V1 at C1, V2 at C2, V2 at C2. This case, what is the equivalent capacitance na? C equivalent equal to 1 by C1 plus 1 by C2. This is the formula. See, when capacitors are connected in series, charge is same. What is divided? Potential is divided. So potential is divided. So we can write it what now here? V equal to V1 plus V2. It's not total potential across the capacitors, which is equal to sum of the potentials V1 plus V2. Actually, CQ equal to what? CV. Here, V equal to what we can write? Q by C. Here, see total potential na we can write Q by C. Yes, means charge is same na. So Q by CQ, C equivalent. Here V1 na Q by C1 plus Q by C2. Q is common and cancel. What we get? 1 by C equivalent is equal to 1 by C1 plus 1 by C2. It is the formula when capacitors are connected in series. Capacitors are connected in series. 1 by C equivalent equal to 1 by C1 plus 1 by C2. This one, now, for example, 2 capacitors is there. We can 3 is there, now 1 by C3, 1 by C4, like that is there. See, for 2 capacitors are connected in series, now that case C equivalence shortcut formula is C1 C2 by C1 plus C2. This is the formula for C equivalence. When the capacitors are connected in series, charge is same, potential divided. What is the equivalent capacitance? Na? C1 C2 by C1 plus C2. Yes, na? For example, see here, capacitors are connected in parallel. This is the parallel connection. This case, see, this is a parallel connection. Here C1, here C2 is there. This case, see, here charge is Q1 entered. Yes, na Q entered. If this charge is divided here, Q1, Q2 here, potentially same at V and V. Here potential same. Here also potential same. Means when capacitors are connected in parallel, charge is divided, potential is same. Capacitors are connected in series, charge is same, potential is divided. So this case here na charge equal to what? Q equal to Q1 plus Q2. Yes na? See, Q means what? CV na, we know capacitance into potential. See, here we can write C equivalence, potential same na, here C we can write here C1 V plus C2 V common and cancel. What we get? C equivalence equal to C1 plus C2. When capacitors are connected in parallel, potential is same, charge is divided, total charge equal to sum of the charges. So in this case, what is the total capacitance? Equivalent capacitance, that is sum of the capacitance. Parallel connection na just added. Series connection na reciprocal of equivalent capacitance is equal to sum of the reciprocal of the individual capacitances. So that means we can write C equivalent by 1 by C equivalent equal to 1 by C1 plus 1 by C2. From that we can write C equivalent equal to C1 C2 by C1 plus C2. This is the shortcut for when two capacitors are connected in series. This is the shortcut for when two capacitors are connected in parallel. C equivalent equal to C1 plus C2. Here C equivalent equal to C1 C2 by C1 plus C2. Yes, na? Now we can go to the problem. See here, what now here? Which one is parallel? Which one is series? We can check first. See here, in this case, here C1, C2, C3, C4. These two are series. Why not? See here, end to end connection is there. We can write C1, C2 and C3 are series connection. Series connection. C1 is what now here? 100 picofarads. C2 is 200 picofarads. C3 is 200 picofarads. C4 is 100 picofarads. This is the values they give in problem. This case C2, C3. See, this is 200 picofarads. This also 200 picofarads. First we can solve this one. So means equivalence. C23 equal to, what is the formula? C2 into C3 by C2 plus C3. Yes na? C23 equal to, C2 is what? 200 into 200 by 200 plus 200. What we can write na? 200 into 200 by 200 plus 200, 400. Here see the two zeros cancel. Two ones, two twos. Here two ones, two hundreds. What we get now? C23 equal to 100 picofarads. What is the resultant now? C23 equal to 100 picofarads. See, C2, C3 are connected in series. That case, series connection 200 picofarads, 200 picofarads. Series connection, what is the formula? C equivalent equal to C2 plus C3 by C2 plus C3. Means C1, C2 are in series. That case we can write C equivalent equal to C1, C2 by C1 plus C2. This is the formula. So we can use here C2, C3 are in series. C2 into C3 by C2 plus C3. So C23 equal to what? 200 into 200 by 200 plus 200. What we get? So simplify now, we get 100 picofarads. So means this resultant now 100 picofarads. 100 picofarad. I draw here circuit now. See, this is I erase this one. See, now see that circuit will be changed now. See, I write here. See, now this one is there. For this 2 we can write it as this one. This is what now? 100 picofarads. 100 picofarads. Resultant we get here is already given 100 picofarads. See, it is connected to one more, that is also 100 picofarads. 100 picofarads, this one. See, what is the voltage now here? V equal to 300 volt. V equal to 300 volts. So see here, charge is moving this direction. Here two ways is there, in this one, in this one. Here divided charge, here q1, here q2. See, here q charge is divided, again here coming here, and here q2, here q1, both combined, here q is the total charge. So means here divided, where divided there, that is our parallel. Charge divide na parallel, in this case potential is same. Yes na. See, here divided, so again combine here this charge. So means this will be series, these two will be parallel. So that's why we can find out these two. What is the resultant of these two? This is 100, this is 100 picofarads. So it is C1. So means C1 and C23 are parallel. Parallel na. So parallel means what is resultant? C equivalent equal to, C equivalent means C123 equal to C1 plus C23. C23 is what? 100 picofarads. C1 is 100. 100 plus 100, 200 picofarads. See, C123 equal to 100 picofarads. See, once again, see here charge is here coming, here divided, here Q1, here Q2. It will be coming here, again combine here and coming out. So means where divided, that are in parallel. So means this is C1 and resultant of C23, both are in parallel. So parallel means what is the resultant? C1 plus C2. So means C1 plus C23. So C1 is what? 100 picofarads. This resultant is 100, 200 picofarads. These two are over now. Yes, na? Now these two over now. What is the next circuit now? See here, this one. What? C123. Here C4 is there. C4. This here 300 volt is there. See these two now. See here, Q charge coming, entering same. So charge same, potential divided. Here V1, here V2. So means this is in series. So means here C4 and C123 are series connection. Series connection na, C equivalent equal to what? C1 C2 by C1 plus C3. Yes na. See, C equivalent equal to, C equivalent means 1, 2, 3, 4. 1, 2, 3, 4. That equal to C4 into C123 by C4 plus C123. C4 is what here? 100 picofarads. It is what we get now? 200 we are getting before. 200 picofarads. These two we can check. So C4 is 100 into 200 by 100 plus 200. What we get now here? C 1, 2, 3, 4 equal to 100 into 200 by 100 plus 200, 300. these two zeros cancel. 2 means 200 by 3 picofarads of equivalent resistance. Total equation na, what is the equivalent capacitance na, not resistance, capacitance. What na, C equivalent equal to 200 by 3 picofarads. So means here voltage is what, 300 volt. So we want here what is the charge. Charge equal to what, C into V. C means what here, equivalent total capacitance. So 200 into 10 power minus 12 picofarads equal to 10 power 1 pico equal to 10 power minus 12 into 3 into voltage 300. Here this, sorry, 3 ones means 300s, 3 ones, what we get now, 200 into 10 power minus 12 into 100. See here how many 1 2 3 4 zeros now, these 4 zeros we can reduce here 4. So means 2 into 10 power minus 8 coulombs. What is the charge present in the circuit now? 2 into 10 power minus 8. See here, for this, for this 100 picofarads, for this resultant 200 picofarads we get. So finally here what now, C4, and this resultant will be series. That case we are getting C equivalent equal to 200 by 3 totally. In that one, what is the voltage na, 300. So we find out charge. Charge equal to what, CV, capacitance into voltage. Capacitance is what, 200 into 10 power minus 12. Voltage is 300. 3 ones 300s, 100 into 200. Here 2 zeros, here 2 zeros, 4 zeros we can remove. 10 power 4 we can write. 10 power minus 12 plus 4 means minus 8 we get. Charge equal to 2 into 10 power minus 8. What is the charge in the total charge in the circuit na, 2 into 10 power minus 10. Total capacitance is 200 by 3 picofarads. What is the voltage na, this one.